Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide for DTC P0172, indicating that the fuel system is too rich in a 2023 and newer Honda Accord. This code signifies an issue where the engine's fuel mixture is overly rich, meaning there is an excessive amount of fuel compared to air in the combustion process. This abnormality triggers the Powertrain Control Module, PCM, to store the DTC for future diagnostics. The PCM is a crucial component located in the engine bay that monitors various parameters to ensure efficient engine performance. A primary diagnostic tool required for the functions outlined is the vacuum pump/gauge, rated for 0 to 30-inch in Hagen, such as the Snap-on YA4000B. Understanding the problem thoroughly is essential before proceeding to the troubleshooting steps to ensure effective diagnosis and resolution. DTC P0172 occurs when the PCM identifies that the long-term fuel trim, LTFT, is below a defined threshold, indicating a rich fuel condition. The LTFT is a countermeasure that the engine control unit employs to adjust the air-fuel mixture over time to achieve optimal combustion. When LTFT drops below an acceptable level, the PCM concludes that there is too much fuel in relation to air, triggering this diagnostic trouble code. This rich condition can lead to increased fuel consumption, higher emissions, and possible engine performance issues. Key components affected by this code include the manifold absolute pressure (MAP) sensor, mass airflow (MAF) sensor, and various fuel system elements. Each of these components plays an essential role in regulating and adjusting the air-fuel mixture, making them critical in diagnosing why the engine is running rich. Several factors can lead to DTC P0172 being triggered. One primary reason is a faulty air-fuel (AF) sensor, which may not accurately report the mixture of air and fuel entering the combustion chamber. Additionally, malfunctions in the MAF sensor can yield incorrect measurements of airflow, crucial for maintaining the proper air-fuel ratio. Another potential cause is fuel contamination, where impurities in the fuel can disrupt the ideal mixture. Vacuum leaks can introduce extra air into the engine, confusing the PCM and leading it to adjust by adding more fuel. Lastly, faulty injectors can also contribute to excessive fuel delivery, exacerbating the rich combustion issue. Each of these components requires careful inspection to pinpoint the source of the problem effectively. When DTC P0172 is present, various symptoms may manifest, indicating a rich fuel condition. One of the most evident signs is a rough engine idle, which can lead to unstable engine performance. Motorists may also notice increased fuel consumption as the engine compensates for the rich mixture, resulting in less efficient operation. Another alarming symptom includes black smoke from the exhaust, a clear indication of unburned fuel being expelled. Drivers may also experience an overall decline in engine performance, such as sluggish acceleration or decreased power output. Recognizing these symptoms early can prevent more serious engine complications and ensure timely repairs. The first troubleshooting step involves starting the engine and allowing it to idle without any load. This can be done while the vehicle is in either the park P or neutral N position. After the engine has been started, the next step is to monitor the HDS, Honda Diagnostic System, for the short-term fuel trim STFT value. It is essential to check if the STFT value is less than 0.79. If this value falls below the specified number, it confirms that the failure has been duplicated, indicating a rich fuel condition. Collecting this data is crucial for proceeding with further diagnosis, making it imperative that this step is performed accurately. In the second step, it is vital to review the onboard snapshot displayed in the HDS to record what the STFT value was when DTC P0172 was set. This historical data helps in understanding the conditions that led to the issue. After recording the snapshot information, the technician should test drive the vehicle under similar conditions that existed when the DTC was triggered. This includes maintaining consistent engine speed, vehicle speed, the relative throttle position, RELTP sensor readings, and the accelerator pedal position, APP, sensor values. The goal is to see if the STFT value exceeds 0.79 during this test drive, which would successfully duplicate the failure, guiding the technician in the next steps of the troubleshooting process. The third troubleshooting step requires conducting a fuel pressure test to ensure that the pressure levels meet the expected specifications. This involves checking the fuel supply system components, particularly focusing on the high pressure side of the fuel system. It's essential to connect the necessary diagnostic equipment to accurately gauge fuel pressure. The HDS should then be leveraged in conjunction with the observations gathered from the fuel pressure test. If the results indicate a normal reading, the technician can proceed. If not, further troubleshooting will be needed based on issues indicated by DTCs P0087 or P0088, which relate to fuel rail pressure abnormalities. The fourth step centers around inspecting the mass airflow, MAF, and intake air temperature, IAT sensors for proper functionality. Begin by starting the engine and allowing it to idle, ensuring that specific conditions are met. The HDS ECT sensor 1 must be above 158 degrees Fahrenheit, 70 degrees Celsius. The transmission should remain in park, P, or neutral, N, and all engine and electrical loads need to be turned off for accurate readings. Once those conditions are verified, the technician should monitor the HDS while maintaining the engine speed at 2,500 RPM for a duration of 30 seconds. During this time, the MAF sensor values should ideally range between 4.1 grams per second and 5.7 grams per second. Should the readings fall outside this range, it indicates a potential problem that requires immediate attention. Next, in the fifth troubleshooting step, technicians should inspect the engine oil for any signs of fuel contamination. Start the engine and let it idle. Then gently pinch the positive crankcase ventilation PCV hose to create a controlled environment for monitoring the HDS data. The primary focus should be on the STFT value displayed. It must be less than 0.79 for normal operating conditions. If the STFT value indicates otherwise, this points towards possible fuel contamination in the engine oil. It's crucial to identify the source of contamination, which could stem from various issues such as faulty injectors. If fuel contamination is confirmed, a necessary step is to replace the engine oil and oil filter to restore normal operation and prevent further damage. In the sixth step, the focus shifts to evaluating the EVAP evaporative emission control system canister purge valve for any faults. Begin by ensuring the EVAP canister purge valve connector is disconnected and the vacuum hose from the purge line is detached. Connect the vacuum pump or gauge rated for 0 to 30 inches to the purge valve. With the engine running at an idle, monitor the gauge to check for vacuum. According to the diagnostic parameters, if there is no vacuum present, the system is functioning within normal limits. However, if vacuum is detected, it signals a malfunction in the canister purge valve, which could cause excessive rich fuel conditions by introducing fuel vapors into the intake manifold. The seventh troubleshooting step focuses on inspecting the fuel quality in the system. Since no direct testing method exists for fuel inspection, the technician should use a known good fuel sample to verify system integrity. This process involves draining the current fuel from the tank and refilling it with known good fuel. Following this refueling, test drive the vehicle to see if the conditions associated with DTC P0172 can be reproduced. If the failure persists, it indicates underlying issues with other components. However, if DTC P0172 vanishes along with any symptoms, this clearly points to the original fuel being at fault, requiring replacement to ensure optimal engine performance. In this step, the technician is tasked with examining the AF sensor, sensor 1. The method applied here involves replacing the suspect AF sensor with a known good component to evaluate functionality. Given that there is no direct method for checking the AF sensor, utilizing an effective replacement is the next best avenue to troubleshoot the issue. Once the new sensor is installed, if DTC P0172 is still present or symptoms are replicated, it would indicate that other components in the fuel system may be causing the problem. If the symptoms disappear, the initial AF sensor is confirmed faulty and needs replacement. Step 9 focuses on inspecting the fuel injectors, again using the known good component approach for effective diagnosis. The intention here is to install a functioning injector to see if the fault persists. As with previous steps, this method effectively rules out the known component since there is no direct approach to testing injectors. If symptoms continue or DTC P0172 remains, it may implicate other related components outside of the injector itself. Conversely, if the symptoms resolve, the original injectors are deemed defective. Replacing these injectors should ensure proper fuel delivery and eliminate the rich condition impacting the engine. The 10th and final troubleshooting step shifts the focus onto the powertrain control module, PCM. If previous inspections revealed all components to be in a normal operational condition, it is likely that the PCM has developed faults. The PCM, located within the engine bay, is soft-coated to adapt engine performance and can occasionally fail, leading to erroneous diagnostic readings like DTC P0172. To ascertain whether the PCM is indeed at fault, further testing may be required. If the PCM is confirmed to be defective, replacing it is essential to restore proper vehicle operation and remedy the rich fuel condition indicated by the trouble code. Upon completing all inspections and repairs related to DTC P0172, a final verification procedure is necessary. This involves clearing the DTC from the PCM memory to reset its monitoring system. The next crucial step is to test drive the vehicle under varied conditions to ascertain that the repairs have indeed rectified the rich fuel system issue. During this phase, monitoring parameters such as fuel trim values through the HDS is vital to ensure that all values return to their normal ranges. Ensuring that the DTC does not reappear indicates that the issue has been adequately addressed and the vehicle is functioning correctly. Thorough testing and confirmation are vital for customer satisfaction and long-term vehicle reliability. Preventive maintenance is key to avoiding DTC P0172 and ensuring the longevity and efficiency of your Honda Accord. Regular checks of the fuel system can identify potential issues before they escalate into full-blown problems, thereby saving time and costs associated with repairs. Monitoring the condition of sensors, especially the MAF and AF sensors, is equally crucial. Scheduled cleanings can enhance their performance and accuracy, reducing the chances of false DTC triggers. Furthermore, replacing fuel filters regularly and using high-quality fuel can mitigate risks associated with contamination. Adopting these maintenance strategies not only enhances engine performance, but also promotes overall vehicle health and reliability. In conclusion, Addressing DTC P0172 meticulously is essential for maintaining optimal engine performance in a 2020. Please like and subscribe to the channel. See you next time.